A few years ago, Tesla didn't just build better electric cars, it reinvented the way they were made. The revolution wasn't about sleek designs or futuristic interiors. It was about something far more fundamental: the battery. Tesla introduced the structural battery pack, a radical idea where the battery wasn't just a power source, but part of the car's actual frame. It made electric vehicles lighter, stronger, and more efficient than ever before. That single innovation forced the entire auto industry to rethink how electric cars should be built. Now, a new challenger has entered the race. An American company called 24M Technologies claims they found a way to go even further. A breakthrough so big they believe their new battery design could power an electric car for 1,000 miles, or 1,600 kilometers on a single charge. It sounds almost impossible, but how exactly does it work? And could it really change everything again? Let's break it down. When Tesla unveiled its structural battery pack, it was a true game changer. Before that, electric vehicles relied on bulky, inefficient designs. Battery cells were stored inside modules, and those modules packed into large casings. Most of that structure wasn't doing anything useful. It didn't store energy. It just held things together. Tesla flipped that idea on its head. Instead of hiding the battery inside the frame, they made the battery part of the frame itself, an integral part of the car's body. The result: fewer materials, greater strength, and more space for energy cells. That meant higher efficiency, longer range, and less weight. Chinese giants like BYD, CATL, and NIO adopted their own cell-to-pack and cell-to-body designs. They branded them with different names, CTP, CTB, and more. But the goal was the same: eliminate unnecessary parts, maximize usable space, and squeeze every possible watt-hour of energy into the vehicle. The result was a new generation of electric vehicles that were lighter, cheaper, and easier to produce. Yet even with these advances, there was still one major problem: wasted space. A surprising amount of every battery pack was still filled with parts that stored no energy at all. And that's the inefficiency 24M Technologies wants to eliminate completely. Even in the most advanced structural battery packs, much of the space is taken up by thousands of individual cells, each sealed in its own metal or plastic casing. Those casings are important. They prevent short circuits and overheating, but they don't actually store energy. They're safety wrappers, not power sources. To 24M, that's an enormous opportunity. If you can remove the dead weight, you can unleash the battery's true potential. According to 24M Technologies, only 30 to 60% of a traditional battery pack's volume actually stores energy. The rest is wasted space filled with structural components and safety materials that don't power the car. That's where 24M comes in. Instead of thinking about batteries as lots of small cylinders or pouches inside a box, they've designed something entirely new. Their idea removes the cell casings altogether and integrates the energy-storing parts directly into the battery pack itself. 24M Technologies, based in Massachusetts, has developed a concept they call Electrode-to-Pack, or ETOP. It's a fresh way of thinking about energy storage. According to 24M, this design could make up to 80% of the pack's volume active, compared to only 30 to 60% in current batteries. That's a massive jump in efficiency, potentially doubling the energy density. That's why 24M believes a 1,000-mile range is possible using this approach. As exciting as it sounds, 24M's concept isn't ready for mass production yet. One of the biggest hurdles is manufacturing scale. The global battery supply chain is currently built around familiar designs: cylindrical, prismatic, or pouch cells. Entire factories, supply chains, and quality control systems depend on these shapes and processes. Switching to an electrode-to-pack method would mean redesigning everything from production lines to safety testing, and that could cost billions of dollars. Manufacturers would need strong proof that this new system is worth the investment. Another major concern is repair and maintenance. Traditional battery packs can isolate damaged cells without affecting the whole system. If one cell fails, technicians can replace that module. But in 24M's fully integrated design, there are no separate cells or modules. So, what happens if part of the pack fails? If one section malfunctions, could it take down the entire battery? Would mechanics need to replace the whole thing? That's still unclear, and it's one of the most serious practical concerns for real-world use. Despite these challenges, the potential benefits, longer range, higher density, and lower cost, make this technology too promising to ignore. When you first hear 1,000-mile range, it sounds unrealistic, but technically, it's possible. Remember, 24M isn't changing the chemistry. They're just using the space better. If they can fit twice as much active material in the same size pack, they can roughly double the range. The company claims this approach could work with existing lithium-ion materials, meaning automakers wouldn't need entirely new raw materials or supply chains. That's a huge advantage. Still, proving this in real cars will take time. Battery technology is honestly one of the toughest fields to commercialize. So many companies show promising lab results, but they often fail to scale. Mass production requires years of testing, safety validation, and real-world trials. 24M has been developing advanced lithium-ion designs since 2010, and they're known for practical, step-by-step innovation. That gives their claims more credibility than startups promising revolutionary solid-state solutions. So, the ripple effects of such a breakthrough would extend far beyond just passenger cars. Electric trucks, which, well, currently face significant range and weight limitations, could become vastly more practical and economical. The viability of electric aviation, which demands extremely high energy density, would receive a tremendous boost. Even grid storage solutions could benefit from more compact and cost-effective battery systems, really accelerating the transition to renewable energy sources. In essence, 24M is attempting to do for the battery cell what Tesla did for the battery pack: eliminate an entire layer of redundant structure. This philosophy of deep integration and simplification is honestly a powerful driver of technological progress. While the path forward is uncertain, the pursuit of such ambitious goals is what pushes the entire industry forward. Whether 24M's specific e-top design becomes the standard or simply inspires the next wave of innovation, its impact is already being felt by challenging the fundamental assumptions of how a battery should be constructed. The race for the next generation battery is on, and the finish line is a future where electric vehicles are the undisputed norm, not just a compelling alternative. The promise of such a design extends beyond just raw range. By simplifying the architecture and removing layers of inactive material, 24M also targets a significant reduction in manufacturing cost and complexity. Fewer parts mean fewer assembly steps, less material handling, and potentially faster production lines. This aligns with the industry's relentless drive to make electric vehicles affordable and accessible to a broader market. The Electrode-to-Pack approach isn't merely an incremental upgrade. It's a fundamental re-architecture that challenges a century of assembled battery design. If 24M can demonstrate consistent safety, efficiency, and recyclability, their Electrode-to-Pack batteries could completely redefine how EVs are built. It might not happen overnight, but this could be the next big step in the electric revolution. Just like Tesla's structural battery once was, innovation in batteries has always driven progress in electric vehicles. Tesla's structural pack showed how integration could unlock more power and range. Now, 24M's Electrode-to-Pack design aims to push those limits even further, eliminating waste, reducing cost, and potentially giving EVs an incredible 1,000-mile range. But challenges remain. Scaling up production, ensuring safety, and creating repairable systems are no small tasks. Still, even if the full 1,000 miles isn't achieved immediately, any improvement in energy density is a huge win for the industry. This new direction could reshape how electric cars and even aircraft are built in the future. If 24M's idea works at scale, It won't just extend range. It could redefine what's possible for sustainable transportation worldwide. The next evolution in battery design may have already begun quietly inside a Massachusetts lab.